Hi friends, in this session we will discuss an interesting concept, recursion. First of all, let's see an example of computing 3 raised to 5. You would calculate 3 raised to 5 by just multiplying 3 with 3 for 5 times. There is another way to calculate the answer. Note that 3 raised to 5 equal to 3 into 3 raised to 4. So if you know the value of 3 raised to 4, you could easily calculate 3 raised to 5. In the same way, 3 raised to 4 is calculated by 3 into 3 raised to 3, and so on. This second way of doing the power operation is known as recursion. Observe the program of computing power recursively. In this code, the function 3 raised to is a function that calls itself. This is known as recursive function. Now let's see how to find a factorial of a number using recursive function. Observe the factorial function. Let's understand this function with the help of an example. So let's find the factorial of 6. We will represent the computation graphically. As you can see, function factorial of 6 calls function factorial of 5, which in turn calls factorial of 4, and so on. After that function, factorial of 0 returns value of 1 to factorial of 1. Factorial of 1 returns value of 1 to factorial of 2, which in turn returns value of 2 to factorial of 3. Then factorial of 3 returns 6 to factorial of 4. After that, 24 is returned to factorial of 5. That in turn returns 120 to factorial of 6. Finally, 720, that is factorial of 6, is returned to the main program. So friends, you might wonder how recursion is managed by operating system. This is a classic example of application of stacks. For that, consider the following example. Now can you tell me what happens when function f2 calls function f1? So here the computer stops executing function f2 and starts executing function f1. After the complete execution of function f1, it returns back to function f2. While it is executing f1, the state of f2 and information of f1 is saved on the stack. This information that is saved on the stack is called as activation record. After the execution of the function, memory of the activation record is deallocated. An activation record stores the details of the called function like storage space for all local variables of called function, return address of caller function, etc. So in short, when a function is called, its activation record is pushed onto the stack, and after the called function's execution, the control returns to the caller function with the help of return address field from the activation record. Recursion uses self-calling functions. These functions get executed with the help of activation records of themselves until the condition of recursion is false. Recursion finds applications in many algorithms such as Fibonacci series, linear search, binary search, and quicksort. It is also used in merge sort, tower of Hanoi, tree traversals, graph traversals, and many more. Interesting, isn't it?